Example problem 4 is a continuity of flow equation. So in this problem, there's a building and water is being delivered to the building underground. So there's a big pipe and then it narrows itself down into a smaller pipe. And so both of these pipes have an area, so a big area and a small area. And then they also have the velocities of water traveling through them. So you have water traveling through here. Once it hits this point and goes into a smaller pipe, the velocity is going to change. And so oftentimes the problem is going to ask us for what that changed area is or what the changed velocity is in the second pipe. So that being said, since this is a continuity of flow problem, we're going to use the continuity equation. And so the continuity equation is A1 squared V1 equals A2 squared V2. So the problem reads, water often flows underground from a larger pipe into a smaller pipe as it's being delivered into buildings for everyday use. So we know we have a big pipe. And then we know we have a small pipe based on the drawing that we did up here. So we can go ahead and draw out our A1 and our V1. We can go ahead and write out our A2 and our V2. So at the Fran U Science Building, water passes from a larger 1.0 meters squared pipe. So there's our first area, 1.0 meters squared. At a velocity of 6.0 times 10 to the 7th meters per second. That's our first velocity. To a smaller pipe, so now we are going to the other side over here on the small side. To a smaller 0.5 meters squared pipe. So 0.5 meters squared is going to be our second area. What is the velocity of the water entering the science building through the underground pipe? So the smaller pipe. So very important whenever you're plugging these variables in, don't forget to square your areas because if you do, the answer will be wrong. So the first one's pretty easy to square. 1 squared is obviously going to be 1. So 1 meter squared. For the velocities, you don't have to do anything to them. You just bring them over into the equation. So our V1 is 6.0 times 10 to the 7th meters per second equals A2 squared. So in your calculator, you actually have to put this one in. 0.5 squared is 0.25 meters squared. And X, or you can write V2 there, it doesn't matter. But that's ultimately what we're going to be looking for, is going to be this velocity here. So to get X by itself on this side of the equation, we have to divide by 0.25 meters squared to get that to cancel. Divided by 0.25 meters squared. 1 times anything is going to be itself, so you can pretty much cancel this out for this problem. And this turns into 6.0 times 10 to the 7th divided by 0.25, and that is going to be, in scientific notation of course, because this is a really big number, 2.4 times 10 to the 8th meters per second. These problems are easier when you draw them out in the beginning so that you can see what's happening. But it's pretty easy to identify even by itself if you don't draw it out, if you look at the problem carefully. It's usually pretty clear where the big pipe is and where the small pipe is and which area and which velocity corresponds to which pipe. So thanks, and let me know if you have any questions about example problem 4.